differently because I put it in factored form. So I am asking us to graph everything here just like we were doing. So we're going to do critical points, increasing and decreasing, max and min, inflection points, and concavity. So exactly what we are doing on those that problem we just worked out. We have a couple of options. We need to get the derivative of this. You could choose to multiply this all out first. You know, if it were just two parentheses, I would probably do that. I don't know that I really want to multiply this one. So you have to do the x minus 1, square that, and then distribute. If I don't multiply it out first, what would I have to do to calculate my derivative? Product rule. We can do that. So product rule, derivative of the first, so the 2 comes down, inside stays the same, subtract 1 from the power, times the derivative of the inside, which is just 1, so I don't need that, times the second, plus the first, times derivative of the second. What is the derivative of the second? All right. So there's some options for what to do here. We can multiply all this out. We know this. What do both of these terms have in them? X minus 1. Why don't we factor that out? So if I take out my x minus 1, then I'm left with 2 times x minus 2 plus, it was x minus 1 squared, so if I took out one of them, we just have an x minus 1. So if we simplify, can I combine steps here? I need to distribute the 2 and add like terms. So that would be 2x plus x is 3x. Minus 4 minus 1 is minus 5. Have I lost anybody there? Now this isn't the only way to get here, but it's probably the easiest because now, can you tell me what your critical points are? What are they? 1. So that's the first thing I asked for. Now we want increasing and decreasing. So what do we need to do? So smaller than 1, maybe a 0. In between 1 and 5/3. So 5/3 is like 1.6 repeating, so let's say 1.5. And bigger than 5/3, maybe a 2. So if I plug in a 0, we have a negative times a negative, which is positive. Plug in 1.5, we get positive times negative, which is negative. Put in 2, positive times positive is positive. So where is this increasing? It's going to be 2, 1, and it's 2 infinity. And then it is decreasing between 1 and 5/3. Okay, that's the second thing I asked for on my list. I said local and absolute max and min, but since I didn't give you stopping points, do we have any absolute maxes here? No, so we just need the local max, which we can get right now. At 1, our graph was increasing and switched to decreasing, so that is max or min? Get the ordered pair, you plug that into the original. So if I put a 1 into the original, we get out 0. At 5/3, we were decreasing and switched to increasing, so that is a min. we plug 5/3 in. 5/3 minus 1 is 2/3. Squared would be 4/9. 5/3 minus 2 is -1/3. So we get -4 over 27. That was the next thing on my list. Alright, now I want inflection points and concavity. So what do we need? We just found everything we can do with the first derivative. Second derivative, I'm going to work it from here, but we'll have to do product. So derivative of the first, derivative of x minus 1 is 1, times the second, plus the first, derivative of the second. Derivative of 3x minus 5 is 3. Is 6x minus 8. So inflection point, you set that equal to 0. And you get 4/3. Ultimately, we'll have to be able to mark this on the graph, so you have to plug 4/3 back into the original. So we'll need that y value. 4/3 minus 1, so 4 over 3 minus 3 over 3 is 1/3. Squared is 1/9. 4/3 minus 2, so 4 over 3 minus 6 over 3 is -2/3. So we get -2 over 27. You guys understanding how I'm getting these order pairs? So now we need concavity. So what do we need to do? We only have to mark the 4/3. So something smaller and something bigger. If I put a 0 into my second derivative, we get a negative. If I put in a 2, we get a positive. So this graph is concave down from -infinity to 4/3, and concave up from 4/3 to 1. So we found everything, now we just have to graph it. So, inflection point we mark with an X. This is going to be a little bit tricky because these points are pretty tiny, but we'll do the best we can. So 4/3, that's like 1 1/3. -2 over 27 is a very small negative number. All right, my max was at 1, 0. And my min was at 5/3, so that's like 1 2/3. And -4 over 27. So just a little bit lower than the inflection point there. All right, so if we look at this, our graph starts increasing until we get to our max. We are concave down until we get to our inflection point. So we're increasing but curved downward. We have to switch to decreasing, still curved downward, but once you hit that X, you have to switch so you're kind of curved upward. And then after my minimum, we switch to increasing, but we're still curved upward. So our graph looks something like this. debating if I want to do the next one. I think I'm going to stop here. And I'm going to give you guys some problems to do. Okay, so tomorrow we will do this final example. It's got something a little bit different in it. It's going to have some asymptotes, so we'll start that tomorrow. So for now, I want you to do some book problems today.